Hello students, welcome to Educate. In previous lecture, we have studied the concept of cross product, and now we are going to see the applications of cross product or vector product. So suppose you are given two sides of a triangle and those sides are represented by two vectors. Suppose vector A and vector B, this is triangle. You can take three sides also, there is no problem. So just consider these two sides. If you find the cross product of these two sides, that is A cross B, and you take its modulus. So what you get, just divide it by 2 to get the area of the triangle. So you can say, if we take any two sides, suppose we take A and C, so area of triangle will be equal to modulus of A cross C, or 1 by 2 modulus of B cross C, are equal to 1 by 2 A cross B. So you can take any two adjacent sides and find their cross product and then find half of it. After finding cross product, you have to find out its magnitude, then you will divide it by 2 to get the area of the triangle. So this is one concept. Another, suppose you want to find out area of a parallelogram. So here there are two possibilities. If two adjacent sides are given, suppose this is vector A, this is vector B. So area will be equal to just A cross B. Obviously, it will be double of area of the triangle. In case of triangle, what you have done? You have just found A cross B and modulus thereof, and then you have divided it by 2. Here, you don't have to divide it by 2. Now, another situation is there when you are given a parallelogram. So this is a parallelogram in which this side is A, this side is B, and also its diagonals are given. Suppose this is D1 and this is D2. So if we don't want to use the concept of cross product of sides, then what we can do? We write area is equal to 1 by 2 cross products of its diagonals. So what you have seen, area of triangle is cross product of two adjacent sides divided by 2 in terms of magnitude. Area of parallelogram or rectangle will be cross products of two adjacent sides and its magnitude. And then area of parallelogram can also be found by finding cross products of the diagonals and then getting its magnitude and dividing it by 2. Here, this question is simple. A and B are given, two vectors, and you have to find out A cross B. And I have already taught you how to find A cross B, so I'm not going to tell you. Now, suppose you want to find out a vector, that is unit vector, perpendicular to two given vectors. Suppose one is vector A, another is vector B, and you have to find out a unit vector which should be perpendicular to both A and B. So you can write vector n cap is A cross B divided by modulus of A cross B. We will see it. Here, find the area of triangle whose sides are given. So here three sides are given. As I told you, you can take any two sides and find the area. So suppose you want to find out area. So for this, say let's write it as delta equal to half of modulus of. So first of all, you should not apply formula here. First, you should take any two sides and find its cross product. Suppose one side is vector A, which is this much, and another side is vector B. Now we are going to find out the cross product. So A cross B. will be equal to, take here, put I cap, j cap, k cap, then coefficients 3 minus 2 and 1, then 1 minus 5 and 1. Now if you remember, I told you A cross B will be equal to, take I cap outside and then leave that column and that row, and then multiply minus 2 into 1. So minus 2, put minus sign, so these two minus sign will become plus, so minus 2 plus 5 will give plus 3. Then for j, you have to take negative sign, leave this column and this row, 3 1 is 3 minus 1, so you will get 2. Then vector k cap, here if you leave this column, this row, so 3 5 is 15, minus 15 and plus 2, so minus 13. So you have got a vector A cross B, and that is equal to A cross B you have got as 3 I cap minus 2 j cap minus 13 k cap. Correct. Now find its modulus. A cross B modulus, so it will be equal to 3 square plus 2 square plus this is 13 square. So area will be half of this value. So first question is done. You can also do, you can take this side and then find the cross product and then find its magnitude and then divide it by 2 to get the area. So this question can be done the way you like. Now find the area of the parallelogram whose adjacent sides are given. Again same thing is to be done, as I told you that you will find, suppose adjacent sides are A and B, so find A cross B, put the values like I cap, j cap, k cap, then write 2, minus 2, 1, 8, 4, 5, then evaluate it. So evaluation you know very well, you will leave this and this, so minus 10 minus 4, so minus 14, then minus j times, leave this and this, so 2 5 is 10, 10 minus 8 is 2, and then take k times, leave this, so this is 8 and plus, because one more minus you are going to add, so 8 plus 16, 24. So you have got minus 14 I cap minus 2 j cap plus 24 k cap. Now this is A cross B. Since area of parallelogram is modulus of A cross B, so you can write delta equal to, modulus means square root of 14 square plus 2 square plus 24 square, and then whatever value you get, square unit answer will be there. So you have understood. Now third question says find the area of parallelogram whose diagonals are given. As I told you, area of parallelogram when diagonals are given will be, suppose area of parallelogram, sorry, we can write A equals 1 by 2 d1 cross d2. So first of all you have to find out what is d1 cross d2. So d1 cross d2 diagonals are given, you know how to find cross product and then find its magnitude, then divide by 2, you will get the answer. Now let's go to next question. Find modulus value of A cross B if modulus A is given as 10, modulus B is given as 2 and A dot B is given as 12. Can you think? Here, if you remember, A cross B modulus, A cross B modulus will be modulus A, modulus B, and then sine theta. In our question, what is given? Modulus A is given, modulus B is given. Sine theta is not given. We have to find out this value. So do one thing, leave it intact and consider modulus A dot, sorry, vector A dot vector B. It is modulus A, modulus B, and then cos theta, right? A dot B is given as 12, A is given as 10, B is given in magnitude as 2 cos theta. From here, what is cos theta? Cos theta will be 12 upon 20, that is 3 upon 5, 4, 3 times 12, 4 5 slash. Now do one thing, just draw triangle, right angle, 90 degree. This is base is 3 and perpendicular is, sorry, hypotenuse is 5. You understood? A dot B, modulus A modulus B cos theta. A dot B is given in our question, that is 12. So 12 equal to modulus A is 10, modulus B is 2 and then cos theta. Now cos theta you can evaluate 12 divided by 20. So on simplification we get 3 upon 5. So we look at them 3 and 5 because cos theta is base upon hypotenuse. So this will be 4 by applying Pythagoras theorem. Now our purpose will be served. Our purpose is to get A cross B modulus. Modulus A we have 10, modulus B we have 2, and the sine theta from there we can get 4 by 5. So we put the values 10 into 2 into 4 by 5. So this is our answer. I think you have understood. Now let's take next question. Here, what is next question? It says you have to find out A cross B cross C. If A is this much, B is this much and C is this much. It is simple. First of all, try to find out A cross B. You will get a vector. Assume it, so when you find A cross B, suppose you get a vector A cross vector B, sorry. Vector A cross vector B, you denote it as, suppose you have vector A and vector B and you find its cross product. Suppose this is vector D, right? And vector C is already given. Here order is given. In bracket means you have to find out the cross product of A and B first, and after that whatever result you get, you will do cross product with vector C. So you have got vector D and then find D cross C. You will get the required result. I am not doing that. That is for your practice. Now let's see this question, which is little good. In any triangle ABC, prove that sine A upon A equal to sine B upon B equal to sine C upon C, where ABC are sides and capital A, capital B, capital C are angles opposite to these sides in order. Let's see this question. What can we do? So here, suppose you are given a triangle. Suppose this is vector A, whose magnitude is given as vector as small a, not modulus. This is say vector B, whose magnitude is say small b. This is vector C, whose magnitude is say small c. It is already given in our question ABC. So these are vectors, these are their magnitudes. Now it is given that angles opposite to them. So this is angle B. If this is vector A, then this will be angle A, and this is vector C, this is angle C. Now here these vectors are cyclic, means they move in same direction. So in case of cyclic vectors, vector A plus vector B plus vector C gives 0. Now here if we take direction of, we extend this A, so this will be vector A. So angle enclosed between vector A and C, this, since this is straight line, this will be 180 minus C. Similarly, if B is extended to here, this is C, so this angle will be 180 minus A. Similarly here you will get 180 minus C. But fortunately you know that sine 180 minus theta is also sine theta. So no change will occur whether you will put sine 180 minus theta or sine theta, but you have to put 180 minus theta. I will tell how. Now let's take cross multiplication, cross multiplication with vector A with all. A plus B plus C equal to A cross 0, say it is 0 vector. Now, you know, cross product of same vector is 0, 0 plus A cross B plus A cross C equal to 0. Or you can write A cross B equal to minus C cross A. If you change the order, if you know vector A cross vector B is negative of vector B cross vector A. So here you can write A cross B is equal to, this will become C cross A with a negative sign. But here one more thing you have to notice, that direction of C is just opposite. So in this case, if you write correct value, direction of C is this. So because if you remember, I can tell you one more thing so that it may become clear. Suppose this is vector A, this is vector B, these are directed like this. Then third vector, so vector A plus vector B will be vector C. If you take it in this side, if you change the direction, then this will become vector A plus vector B minus vector C equal to 0. If two vectors are like this vector is like, but here in our case, situation is just opposite. This vector is in this direction. So our result will be, in our case, it will be vector A plus vector B plus vector C equal to 0. That is what I said in the beginning, that when vectors are cyclic, means in same direction, if they move, in that case, sum will be 0. So here, what you have got, vector A cross B equal to vector minus C cross A, or A cross C, you can write it. Now, in terms of modulus, if we write, what do we get? So it will be A, B, and angle enclosed between vector A and vector B will be 180 minus C. So sine 180, because A cross B equal to AB sine theta. So this will be sine C. Similarly, this will become AC sine B. Now, if we do cross product by, so we have taken A plus B plus C equal to 0, and in previous case we have multiplied by A. Now this time we are going to multiply by B. So B cross this, so we will get B cross A plus B cross B will give 0 plus B cross C equal to 0. This 0 vector, this will be 0. So B cross A plus equal to, we can write, we take this to other side, minus B cross C or C cross B. We change the order, so C cross B. Or we can write here AB sine C, 180 minus C, as I told you, angle enclosed, so 180 minus C is also C, equal to BC sine A. Again, we can take cross product with C. So the condition that we get, AB sine C equal to BC sine A equal to CA or AC sine B. You have understood? Now, if we divide each term by ABC, what do we get? Sine C divided by C equal to sine A divided by A equal to sine B divided by B. So this was our question. You have understood? Now, let's see next question. Find the value of x for which the two vectors xi cap, 7j cap minus 8k cap and 12i cap plus 28j cap minus 32k cap are parallel vectors. If you remember, if two vectors are parallel, then their cross product is 0. A cross B equal to 0, then A is parallel to B. Here in our question it is given, find the value of x for which the two vectors xi plus 7j minus 8k plus 12y and 12y plus 28j minus 30 are parallel vector. So if they are parallel, then their cross product will be 0. So you can write, take their cross product and equate it to 0. So how will you take cross product? As I told you, sorry. So to take cross product of the two vectors, so let's take its cross product and we equate it to 0. So what are the values? x7 minus 8, I cap, j cap, k cap, x7 minus 8, and then 12, 28 minus 32. 12, 28 minus 32. Now, equal to 0. So, coefficients of I, j, k will separately be 0. So, if you take I cap outside, then you evaluate. What do we get? So, here you can leave. So, multiplication of these two will be 0. 7 into minus 32 plus 8 into 28 will give 0. Plus, not plus, but minus, because j should be minus. So, minus j times. You take this and this. So, minus 32x, this will become plus 96. Then take k. Then you leave this. So, 28x minus 84 equal to 0. As I told you, if this vector is equal to 0, if this cross product is equal to 0, then each term must be 0. So, first term is becoming 0 automatically. Here this term will be 0, here this term will be 0. If you solve it, you will get 3. So, answer should be 3. You have understood. Now, next part is find a unit vector perpendicular to both A and B. As I told you, to find a unit vector perpendicular to two given vectors is, suppose n cap is the unit vector perpendicular to vector A and vector B. So we find A cross B and then divide the value by A cross B. So here thing is simple. You can apply this formula. You can easily get. So there is nothing in it. Now let's see next question. Next question is, here the question is, for any two vectors A and B, show that A cross B whole square equal to A square B square minus A dot B whole square. Now let's see how to get. So A cross B whole square. If you remember, A cross B equal to modulus A modulus B times sin theta. So we can write modulus A square, that is A square. Square of a vector is just a scalar. So B square, and it will become sin square theta. Correct? Now, if you consider vector A dot vector B, you know vector A dot vector B is equal to AB cos theta. If you square it, vector A dot vector B whole square, so you will get A square B square cos square theta. No problem. One more thing you can do. Either you write here 1 minus cos square theta, A square B square and 1 minus cos square theta, and you open the bracket. What do you get? If you open the bracket, you will get A square B square minus A square B square cos square theta, and you have got A dot B whole square equal to A square B square cos square theta. You can write here. So you will get a square b square minus a dot b vectors whole square. So you have got the answer. So this is all for today. In next lecture, we will start with motion in a plane. Thank you, Team Educate.